Okay, so the first thing, I'm going to rewrite the first base as it is. So it will be 2 to the power of 2010. Now, in most cases, when you're doing a question like this, you need to reduce the base here to a base, so sorry, the exponent is 2011 to an exponent which is equal to 2010 plus something else. So I can write this as 5 to the power of 2010 plus 1, like that. Wait, I'm waiting for you to digest it. If you've got a question, you can ask. I want to create a similar exponent. You understand? That's the objective. As long as the exponent becomes equivalent, then I can multiply the bases. So for this question here, the smallest exponent among these two, that is 2010 and 2011, the smallest is 2010. So I can rewrite 2011 as 2010 plus 1. If you understood what I said, just raise your hand. The objective is to create an exponent that's identical for the two bases. The only way you can do that, we have to convert the largest of the two exponents to the smaller one plus another number. So the only way we can do it here is to say 2010 plus 1. Then here, I can use law 1. Here. Law 1 says a to the power of m times a to the power of n is equal to a to the power of m times, sorry, a to the power of m plus n, like that. So this is in the same format as that. So I want to move from the right-hand side of law 1 towards the left-hand side. Okay? So from here now, let me write the denominator. Now, the denominator is what? See, that is 1,000. Do you see that? It's what? 1,000. Right? Now, since it is 1,000, it means I may need, okay, to split the exponent further. Okay? But for now, let me do it this way. So the next thing now is to say all over, this is all over 100 raised to the power of 1,000. Remember, you are not supposed to use a calculator. You are not supposed to use a calculator. You have to show all your working out. Okay? You have to show all your working out. Right? Now, the way that I did it, because here I've got an exponent which is 1,000. Okay? If I do it this way, I might end up having issues. Okay? So the best way would be to split this. See the 2010, I can write as 2,000 plus 10. Okay? And also this one here, I can write as 2,000 plus 10. But for now, let me get on and see what happens. Right, so the next step now, I'm going to use law 1, moving from the right-hand side to the left-hand side. So you get 2 to the power of 2010 times, here it will be 5 to the power of 2010 times 5 to the power of 1. And that's all over 100 to the power of 1,000. You see what I did from here to there? I use the first law from the right-hand side towards the left-hand side. Okay? Then, from here, I can take out a common factor. Okay? I can take out a common factor, but it doesn't really exist, a common factor. This 5 to the power of 1 is not a common factor. The only common factor is going to be the exponent. Okay? It's going to be the what? The exponent. So I can write this as 5, you see this 5 because there's multiplication throughout. I can write this as 5 times, I'm talking about this 5 to the power of 1, times 2 times 5 all raised to the power of 2010. Yes? What about what? The base 100. Okay, for now I don't want to touch it. For now, I'll simplify it later. For now, I don't want to touch it. For now, I don't want to touch it because the numerator is more complex. I need to deal with the numerator. Okay, so I'm going to do it step by step. So this 5 to the power of 1 is this 5 here. I rearrange the position. Then 2 to the power of 2010 times 5 to the power of 2010, I can rewrite it using law number 3. This is law number 3 now. You see that here, the bases are different, but the exponents are what? Are the same. So I can multiply the two bases and put the exponent which is similar outside the bracket. Okay? Are you following that? Then I can now, from here, I can write, I'm going to simplify, I'm going to do it step by step. Now I can rewrite this 100 here. I can write it as 10 squared. Okay? I can write it as what? 10 squared. If I do that, I'm going to create 2000. So if I write it as 10 squared, all raised to the power of 1000, like that, means the exponent is going to become what? 2000. Do you see that? Okay, let me rewrite it this way to avoid the mess up. I'll write it as 10 squared. Outside here, I'll put the 1000. Does that make sense before we move on? Does this make sense? Yes. Okay? Yes? And that is what? Yeah, you can. I'm going to simplify this way. You can take the root of converting that 100 to say 5 squared times 4, which is 2 squared. And I want to do it that way. But the way that you are saying is also correct. Okay? Remember, we are two different individuals. Class, I'm not doing this question from a memo. I'm doing it from my what? From my head. Okay? But what you're suggesting also may make sense. Alright, so from there now, let me simplify. So from here, I'm going to end up having 5 times, this is going to become 10 to the power of 2010. You see that? Huh? Then this is all over. This is going to become 10 to the power of 2000. Are you following? Yeah. This is not the only way, but this is my approach for the question. When I saw the question, this is what came into my mind. But it is not the only way. If you want to work with bases of 5 and 2, it's fine. But I don't want to work with smaller bases, or that work with base of 10. Now, do you see that the base here is the same, the base there is the same? What do you do if you are dividing bases that are similar? Huh? You subtract the what? Exponent. So we can now subtract and say, you can write it this way. I'm going to try and squeeze it here using a different color. Make sure you look there. So this becomes 5 times this 5 here times 10 to the power of 2010 minus 2000. I'm simplifying it. It's becoming smaller and simpler. Okay? Then this becomes 5 times 10 to the power of what? 10. You see that? Then, from here, the only way I can carry on is that, you see that this is a base of 5, that's a base of 10. I can simplify this base of 10 into 5 times what? Times 2. Okay? I can simplify this further. So allow me to do that. So I can write this 5 times, that will be 5 times 2 raised to the power of 10. Then once I do this now, I can end up having, this is 5 to the power of 1. So I'll end up having 5 to the power of 1 times 5 to the power of 10. Okay? You see that? And this becomes 2 to the power of 10. So my final answer, the base is the same here, the exponents are different. So I can write my final answer as 5 to the power of 11 times 2 to the power of 10. You can leave the answer like that. Okay? You can leave it like that. Okay? Even you leave it like this too. It's okay. You can leave it like that. Okay? I'm going to leave it. To use your calculator, what does your calculator say?
So you don't need to find, you can just leave it in the exponent form.
Yeah, you can leave it in the exponent form because the answer here is a very large number. That's what I'm saying. Can you test with your calculator? Put this in your calculator and see what answer you get. Put this expression in your calculator quickly and see what answer you will get.